the 01 is first semester. All right, this is the second semester. So no, this is a receipt paper. All right. So anyway, this is the question on this VHDL. And the other day, okay, I actually make a mistake. I double think about it. Okay, I should put a else if. Okay, cannot be else. Because if else, they straight away, okay, go for this one. Else shift, they will check for this condition. If fulfill, I do this. If not, okay, then I don't do anything. So I just end. Okay, so this part, sorry, I make a mistake here. All right, should be else if, because I'm checking the conditions. This is a condition that I must check. All right. So first question done. Second question, part A is done. Part B is on T flip-flop and part C is on multiplexer, only 2 input. Okay, 2 input. Okay, let's see here. Okay, Changwai, okay, uploaded everything here. So because of my mistake, okay, Changwai also follow. Okay, so this one here changed to become else if. All right. So in this part here, T flip-flop. So because there is we need to know the output condition, then only we can decide, okay, the new output condition. All right. Therefore, we need a signal. Okay, this signal for us to sort of check, and then later on connected to becomes the output of the Q. And here, T clock, you can put in the reset over here also correct. All right, put it over here. Suka hati, like that also okay. All right. So we have architecture behavior of T flip-flop is, make sure the name are the same. All right, name here are the same. Okay, signal, suka hati, what is the name that you want? Then begin process now. Whatever things that we need to confirm and wake up this program or call this programs, okay, to be executed once, I must put it into the process. So begin, I have this, else if, this one, then check if my T is 0, no change for W, else, okay, I toggle my W. Okay, so not W is the same as toggle the W. And if, now this if is with this one, that's why, okay, same line. All right, and later on the end if here is for this one. Okay, so we can see very easily that if there's an if here, I must end. I end my process first, then only I put my whatever is my signal into my output Q here. All right, and end the behave, make sure the name here same as this name. I will check, okay, when I mark the time. You can use different name, no problems, provided, okay, eventually the program can be executed with no errors. Okay, this is the T flip-flop. Later on, okay, the is here at the bottom, I think. Okay, yeah, the multiplexer only 2 input okay. So this one here in standard logic, so 2 input, 1 bit only. If it's more than 2 input, let's say 4 input, remember this one here I must use vector. Okay, vector, because they always come together one. All right. So my F here is a standard logic. Okay, so this part is correct. Multiplexer, same name, correct. Architecture behavior of multiplexer is begin. Now you are going to find that for this combinational circuit, all the inputs here. Okay, for all combinational circuit, all the input here will be into the sensitivity list for combinational circuit, because there is no control input here like clock, okay, to make it work. All right, so any of this input here change, this program will be called up, okay, to execute once. So I begin my process, and I check my sensitivity list. S is the sensitivity list. Case is when S is a 0. This part is read as when S is a 0, you force the F to take the input I0. When S is a 1, you force the F to take the input of T1. All right, so correct case must end. So this begin, okay, is your process. Then another begin for your architecture here, I have to end it with Okay, and this begin is for the architecture, so I end my architecture. Okay, done for this part. Anyone with any question can straight away ask. Okay, next, look at the last parts here. I am actually making use of these three components plus some logic gates here, okay, to form this simple circuit. Okay, now, what is all this actually? Okay, what is all this? Actually, these are my inputs. Okay, it could be is a QA, it could be is a QB, or could be, okay? Question never say clearly, but I look at this part of the question here. This is the input, okay? External input, okay? And external output. So this part here, my external input, of course, okay, clock is another external input plus your reset, okay? Reset. So these are input, output, Q1, my Q0 feedback here. Okay, Q0 is the one that connected to selector of these multiplexers here. All right, so based on this, okay, we are going to describe this circuit here based on VHDL and the component that we have generated earlier. All right, so we need to now go and sort of combine them. So entity circuit is okay. Yeah, you can call it as a circuit. Is okay. I have my input just now. Remember the A, B, and C. Still got A bar. Okay, if you want to call this one here as A bar, no problem. And another one more is the B bar. You can write as this way. It's all right. All right, but add it in as your input. It is not wire. Okay. So with this, okay, we have our input, we have our output. My output here, okay, label as Z. Okay, now architecture structure of circuit is I have signal 1, 2, 3, 4, 5, but this part here, please, okay, transfer to here. And these are standard logic. Okay, next, my component D flip-flop is, I suppose, okay, you just crop, okay, or copy from the D flip-flop component, put it here, and this component, D flip-flop, same thing, we copy, and then make sure copy, because if you arrange it wrongly, then later on, okay, in your port map part, okay, you have problem. Okay, so I have this one, T flip-flop, then I have my multiplexer as well. All right, okay, begin. I start to describe the connections. This part here is I call up all the components already. I call up all components, then I start to describe the component, begin. So if I'm not mistaken, it should be labeled as a D1. All right, so let's confirm here. So this is the name that I'm going to call it for D1. Because you cannot use a D anymore. Okay? Okay, so D1, this is the D1. So D1 is given as these are expressions. All right. So remember to make clear, put bracket. Okay, that's to say I must do this one first, do this one first, do this one first, then only I all them. Okay, must put bracket lah. Otherwise, okay, suka hati saya, okay, which one to do, then eventually, okay, answer all wrong. Okay, D flip-flop 1 here, the first component that we are using, which is keep on check this way, susah a bit. Okay, so this one, we are talking about these components now, the D flip-flops. What is the connection? I need to connect D, connect to D1, clock connect to clock, these R connect to reset, and output is Q1 wire. Okay, so check here. First is input, second is clock, third is reset, fourth is the wire Q1, and double check that this is correct. D1 is connected to your D, go by position. Okay, clock connected to the clock, reset, still reset. Q is the one that you connect to Q1. That's why you always arrange in order so that you don't make mistake. All right, so now same thing. Okay, for this part is correct. Then multiplexer one here, we have Q0, T1. Not sure whether this is correct or not. Check and see. CAQ. CAQ. Now, this part here is connected to C. All right, C we say is a wire ma. A is a here. Sorry, C is the input. A is the input. Input, there's no need to direct connection here. There's no need to declare as wire one. Input and output, okay? Directly connect, no need to declare as a wire. So this is CA. Then this is connected to Q0, our wire that we are going to use. All right, and the output here later on connect to our T. Okay, the T here. Okay, CAQ0 T1 come from the wire T1, and T1 is the one that connected to the Q. Okay, our Q outputs of our T flip-flop. So label something very easy to find. Last one, okay, T flip-flop one here is T1. So you see, if this one you take it as Q, then here I take it as Q. So how these two, okay, can be connected? No. So therefore, this one must be a wire. This wire now join to this point. Okay, this wire now join to this point. Then we have our clock, we have our reset, and Q0 is also a wire. With this wire, you see, you can join to here. Okay, with this wire, you can join to here. So then lastly is our A and Q1, which is a wire from here. Okay, so this wire now becomes input, okay, to our AND gate, and with the A and get our set here. Then don't forget to end your structure. So we are describing the circuit as in this form. Okay, so any questions? So when doing this type of circuit that time, okay, it will be good for you, okay, you put in some name here. Say like this is T1, right? You want to call this one here as T1, for example, like in the descriptions that put down earlier, D1, T1. Okay, this Q1, Q0, I will assign for you. Don't go and change it. Okay, don't change it. You're going to confuse yourself if you change it. Give too many, okay, unnecessary variable. All right, so we add in the D1, T1. Okay, so maybe I put down here, this is the output set. So the two output, okay, Q1, Q0 from the flip-flops here is actually not the output for the circuit, but it's going, okay, to be connected back to the earlier part, okay. These are Q1 to form my output, Q0 connect back to here. All right, so I actually simply created these circuits here. What is the feature? I also don't know. All right, just mainly for exam purpose. Okay, question 1 done. Any questions? Okay, some questions here. This one here, okay? Yeah, university and technology. So long. Next time I want to fill up your this application for job or so. Wow, panjang lebar this one. So do we need to remember the truth table of flip-flops? Yes, all truth table you must remember, Brian. These are the basic, okay, of your digital logic. All truth table, all the gates of truth table you must remember, including the application table. These are considered fundamental. SR and JK also yes. Basic, these are all the basic, okay? Okay, if no question, then we proceed to question number 2. Okay, question number 2 require a little bit of understanding of the question. So read 2 times on your own during the exam if these are things were to come out. So you are required to design a circuit that will add either 2 or 3 to a 3-bit binary number. Okay, this circuit here, I must decide whether I should add a 2 or should add a 3 to this 3-bit binary number. My binary number is x2, x1, and x0. So these are my input. This one here are the input, okay? Then another input comes in called K. K is the control signal. Okay, this circuit should have output. Of course, okay, this 4 forms the output, which represent the 4-bit binary number. So what is the purpose of having K here? When K is a 0 that time, my output so this whole thing is called Y. Okay, so this whole thing here, okay, is called Y. Okay, so Y will be the same as X plus 2. Okay, your X is here. 3-bit, Y is 4-bit. Okay, if K is a 1, then your Y is the same as X plus 3. Here tells you, okay, condition to decide whether your output should plus 2 or plus 3. Okay, actually convert this one here into a truth table. Okay, convert this one here into the truth table. Then later on, derive using Carnot map a minimum sum of product SOP function for output I1, Y3 only, and hence design this one using 2 input NAND gate. You use NAND gate, but this NAND gate got only 2 input. Okay, assume that all complements input are available. Complement means that, okay, in this case here, let's say your X2 bar sudah ada, X1 bar pun sudah ada, okay, S10 all available. Okay, because of these two input here, so circuit may be a little bit more complex lah. That's why, okay, to make it easy a little bit, okay, give you all this available. No need to generate. Okay, then after that, okay, I want a Y0, but now it's in the product of some form, POS. And also, because it's POS, design using NOR gate. And all the complements also available. No need to go and generate. Okay, we understand until here first. All right, with this, okay, of course, the first step now, make sure my truth table here is correct. So here, K is being placed here. Pen, where's my pen? Okay, K is being placed here, and these are the 3 input. So as the standard, okay, arrange them in this form. Okay, make it a habit. After every 4 combination, draw a line. Okay, so now this is a part that I should add to. So whatever here, I plus 2. So this is 0, so become 2, 3, 4, 5. Okay, 3 plus 2. Okay, then 6, 7, 8, 9. All right, next, this one here must plus 3. Okay, so you have 0 here. 3, 4, 5, 6, 7, 8, 9, 10. All right, so the truth table is correct. So easy, right? You are going to get these 5 marks. Okay, after this, okay, we want to have a Carnot map for sum of product Y3. Okay, so I checked already, correct, but I didn't see the expression yet. All right, so this part here is correct. So the Y2, I don't have the answer because question never asked. All right, so then I check for Y0. Yep, this is also correct. Okay, now I need to work out the y3 expressions. Actually, there's no need to write all this. Okay, so away, okay, from the y3 expression, I got this one. Okay, I got this one, which is given as x2 as 1. Okay, x2, yep, correct. Okay, so y2, y1, not us. So if question never ask as tutorial, no problems in the exam, don't waste your time. Okay, but for y0, okay, I think this is not proper because the question require us is the POS. Okay, so POS for this. So I am not going to do this one. I am going to sort of, okay, loop the 0. Okay, loop the 0. And then I'm going to have my k plus x0. Okay, and it with k bar plus x0 bar. Okay, of course, you can convert this one into here, but this question, okay, first ask you to design, so you should actually get these expressions directly from the Kanu map by looping the 0. Okay, look at this y0 again. Okay, I should loop the 0. Okay, so when I loop the 0 that time, my y0, so let's go for this one here first. Okay, so over here, what is not changing? K. Okay, and K is a 0. So everything terbalik. When you see 0, you write 1. Okay, I elevate now this way. My x0 is not changing and x0 is a 0. So I write it as 1. Next, I continue with this one. Now I saw K is a 1, but I am going to write the balik K bar. Next, this one here, now I see x0 is a 1, but I write the time the balik. Okay, so this is our product of some expressions. So straight away get your y0 from here. All right, So then now all these steps here not necessary. Okay, all these parts here, of course, for your own understanding. All right, so straight away give me this one and this one. Okay, now as a question already mentioned that I can take this one as a sample question. Next time I set question the time I ask them to do this. No more chance already. Okay, so I am going to sort of design only Y3, okay, based on NAND gate. So confirm, okay, my Y3 here, is it correct or not? Okay, so based on these expressions here, of course, you can do it as in this case. Okay, so you are going to find that, okay, this part here is easy to form. All right, easy to form. What I have here is x2, x1. I just NAND them first. Okay, so I look at these equations to do it. So I NAND my other long at the back. So I better put it slightly in front. Okay, so first one, okay, I saw the y2, y3. Okay, y2, y3. X2, x1, sorry, x2, x1. Okay, so this part, my problem is on this part. Okay, so in this parts here, what I can do is I suka hati, out of these 3 variables here, I pick 2 of them. Okay, out of these 3 variables here, pick 2 of them. Suka hati, which 2? Okay, so in this case here, I just go in order lah. So k x2, k x2. Okay, so with this one here, you find that, okay, I am going to get my k x2 bar. Okay, I don't want this, so I put a NOT gate here to get my kx2. Okay, I put a NOT gate, I'm going to get my kx2. Then after that, I am going to combine with another NAND gate This another NAND gate, they are input. Take now the last one here is the X0. And with this one here, now you have actually converting. This one here actually forms like a 3-input NAND gate. With this 3-input NAND gate, now I can combine with this one here to form the 2-level NAND gate. So this output, okay, which forms the first term, now going to combine with the second term, come from here. And here you're going to get your Y3. Okay to all? So every time, okay, you try to generate one term first, another term first, then the last level, okay, you go and combine them. Okay, so I need only this one for Y3. And all this, okay, no need to generate because the question say that it's available already. Okay, otherwise the question will be too long, student cannot finish. Okay to all? For Y3, then next we look at Y0. Y0 is easier. Why? Because both terms, okay, are only 2 inputs. All right, so you are going to find that every time this circuit here is 2 level. So, okay, I know them because it's only 2 variables. So you find that, okay, 2 level. You are going to get this one here as Y0. And of course, okay, K X0, that I mentioned earlier, available. All the functions are available. So you can just connect them as in this form. All right. So this is our question 2. Anyone with any questions? Anyone with any questions? Okay. No, then yeah. Okay, then now we try to understand fourth part and fifth part because this is not the final version. Okay, if any mistake, okay, have been corrected. Okay, now implement output Y2 using 8 to 1. Y2, don't go through all this, straight away 8 to 1. Then Y1, okay, Y1, what do I want to do? Okay, 4 to 1 multiplexer and logic gates. Okay, and here, because 4 to 1 here, I decide for you, okay, I told you here, K and X2 here will be our selector input. So you have to make these connections. All right, okay, now look at this one here. Now, Y2, I can actually directly get from this Kano maps here. All right, then later on, okay, transfer it into the multiplexer's input. So there's no need for you to sort of, okay, go and write one more time and so on, okay? So directly use here. So here you use pen to write, then later on, okay, so you use, okay, pencil to write at the side there. So you're going to find that, okay, Sukahati, you question never say that, okay, what are the selector input? So you decide. So of course, when you decide, make it easy for you. Okay, so we use K, X2, X1 as the selector input. And then this is the variable. All right, that is the easiest one now. Of course, if you do differently, okay, I will check, confirm that it is correct. That's all. All right, so I check, okay, this answer from Chan Wai. Okay, so Chan Wai, wow, really very patient. But I don't want to read this one. Headache. All right. Okay, so this part here. Multiplexer. Yeah. So someone is using K, okay, instead of what I suggest. So no problems. We got to decide here. Okay, so there's my pen. Okay. Okay, so he's using this one. So I double confirm because my answer I'm using, okay, K over here. So I double confirm this one here. So for this case here, okay, what we need to check is, I go back to the truth table. So what we need to check is, okay, you all jot down for me. Okay, what I need to check is first line, okay, with this first line. Okay, so because these are my 3 input for the selector, they must be in the same conditions. Okay, so when the selector is at 0, 0 at the time, what do you see at the output? Both are 0. Okay, so first one we are going to put 0. Okay, second one also still 0. Okay, still 0 as the output. Third one still 0. Fourth still 0. All the 4 are 0. Okay, so 1, 2, 3. How many 0 am I having? 1, 2, 3. Yes. Oh, I'm doing Y2. Yeah, a bit blur. Okay, thank you. So Y2, yeah. Sorry. Y2. So 0. Okay. So I think better put it a bit down. So first we look at is a 0. All right, here and here are 0. So put it here so that I can see later. All right. Second, I check 0 here and 1 here. So when K is a 1, my output is a 1. So K. Third, both are 1. Fourth, also both are 1. Okay, so 0, K, 1, 1, first 4 input. Then next 4, check, still 1. This one here, when K is a 0, I got a 1. So put here as K is a 0, so K bar. All right. Lastly, both also 0, 0. So 0, 0, here also 0, 0. So this is my input to the multiplexer. Like I say, okay, question never set any selector, you suka hati, you buat. So if your answer is different from mine, I just double check and do it again, okay, to make sure the answer is correct. So confirm that the answer here now is correct. Mana dia? 0K11, 1K bar 00, 0K11, 1K bar 00. Yeah, correct. Okay, and this is for Y2. Okay, then last part here is a 4 input one. That one you cannot simply buat. So got to follow my sequence KX2. Okay, and over here, these two are the same. Okay, and these two also the same. Yeah, same answer as mine. X1, X0. So actually, there's no need to use sort of like 2 inputs here. What you need to do is just join them. Okay, join them. Then you can save one XNOR gate. All right. But here I never said about the minimum design, so I don't minus mark for this lah. All right. So these are the steps you show. Some students are very smart. Okay, they can see it. Okay, so I don't really check on this part. If your answer is correct, some answer is wrong here, but this is correct, so I still give some marks. All right, so this is correct. Okay, then the part B here. Part B, this is the questions. All right, and convert from max terms here into min term. And this expressions here is the one confirm that you got the right min term or max terms. So you do expansion. Okay, expand. I didn't check this. So you do expansion, then work out, what min terms are these expansions, representing. All right, and 3, 4, 5, 6, 7. Yes, correct. So any number of these, is more than half. So you convert it into the other forms of terms. Okay, from min term you convert to max term, or max term convert to min term. Take whatever is not available here. Okay, so 0, 1, 2. So with this, okay, seems like okay, Chang Wai likes okay active low, so no problems. So if this is active low here, actually we will use AND gate law. Active low. So F3, okay, active low 0, 1, 2 AND gate. So if it's active low, okay, they will generate the max terms, max terms. I'm actually using this active high, okay, output to generate, because I saw 2. Okay, so never mind. So max term F3 0, 1, 2. Then this one here I have to use NAND gates already. So 0, 4, 7. 0, 4, 7 NAND gate. Okay, this one here is the second one here is 0, 6, 7. All right, 0, 6, 7 NAND gate. So provided your combinations of this is correct, so also list down that, okay, this which one is this significant. All right, so this is one of the answer. Another answer for it is using, okay, the decoder here, which is active high output. So maybe can put it inside here. So everything exactly the same. Okay, so I still have 3 input, and this is 210. Any order provided, okay, connection is correct. So 1, 2, 3, 4, 5, 6, 7, 8. So 0, 1, 2, 3, 4, 5, 6, 7. So over here, okay, I don't want to mess up all this. Okay, I go for the simple design. So I use, okay, OR gate for my F1. And this OR gate here, I am going to connect it to 0, 4, 7. Now, in the exam, you can do so. Okay, you can also do it as in this form. So my F2, because label 0 go to 0, 4 go to 4, and so on. So you put here 0, 6, 7. Another one is, okay, F3. Okay, this one here using NOR gate, and you are going to connect it to 0, 1, 2. Okay, so either one. Okay, done for question number 2 here. Anyone, anything to ask? Third questions. Waveform. And waveform is a sure parts that I'm going to set. So, wow, there's no need to read. Okay, I want the, okay, the Q0 and Q1 output from these 2 circuits. And let's check, okay, whether any answer here. Okay, so I based on this. And this circuit here is clock. Is a rising edge. Yeah, clock is a rising edge. So we draw projection line on the rising edge. Okay, all done. Then our clear and preset both are active low. Okay, both are active low. Okay, especially this one. This one here preset. Okay. Oh, I think the drawing here a little bit. Okay. I think this one is like that. Okay, let's check. Yeah. After the 4. All right. So this part here. Otherwise, okay, a lot of arguments. Okay, a lot of arguments. So preset is here. Okay, so with this, okay, we also draw the projection line. Okay, I want Q0. Q0 is actually from JK, from JK, and JK, both J and K are connected to 1. So actually, it's 2 T flip-flop. Okay, actually 2 T flip-flops. So first one here is a question says that question actually never say that, okay, where to start. Why? Because my clear is a 0. Clear is active. That's why they must start from 0. Question never say, but reading from these diagrams here, clear start from 0. So both Q0 and Q1 must start from 0. All right, it's not assume, it's you already set the Q0 and Q1 into 0 already. Then first rising edge comes, nothing will happen because my clear is still working. So these two here asynchronous, okay, working. Then now clear is not working already, I toggle, okay, I toggle. Until here, I still toggle. And because this preset goes low, so they will continue this preset. Okay, let's check my number 6. Number 6. Yep, it goes before pin 6. Clock number 6. So this one here goes before clock 6. Yep, it toggle again. Then toggle, because both not working, toggle, and this preset here is a 0, so becomes 0. So first one is correct. Now, during exam time, okay, if you are given waveform, please trace the waveform. Okay, the answer booklet given to you quite thin. All right, you can put it on the question paper, you trace it. Copy from the question paper. All right, the clock conditions. For this question here, if you were to just write the number, you find that, okay, the clear and the preset conditions are difficult to decide. All right, so you trace, okay, copy the questions, that present your answer as in this form. Okay, now why? So this is the answer that I am going to have. Okay, next. Now we proceed. This one becomes the input, okay, to my second T flip-flop. Okay, so when things happen, okay, my clock will see what is the signal in front. So second clock pulse, I retake this one. So this is correct because of the clear earlier. So second rising edge comes, I check what is the input to me. It's actually a 0. Okay, see what is in front is a 0. So I remain unchanged for T flip-flop. The clock pulse comes, I saw a 1. So I'm going to toggle. Fourth, I saw a 0 again. So remain. Okay, remain until here. Then now I realize that, okay, my preset goes low. Very good for me. Preset goes low means that preset is working. So preset make the output become 1. So I go for 1 until, okay, I see the rising edge at clock number 6. Then I check what is weighted in front of me. Actually, is a 1. So I toggle. Number 7, I saw a 0, then no change. Number 8, I saw a 1 here, so I toggle. I toggle, then suddenly, okay, clock goes low. Clear goes low. Okay, clear goes low, makes my clear here become 0. So correct. All right. So this waveform is perfect, except that, okay, this part here. All right, anyone with any questions? Okay, then no. Hey, are you still with me? Okay. Kiwun, yes. Kiwun, do you do your homework? Okay, now these are state diagrams here. Okay, simple state. You do another paper. Okay, good. So these state diagrams here, okay, will be assigned based on this pattern. I am supposed to design this one here using TK. All right. And these are JK here representing the P, Q, and R output. And they are going to have an input called X, okay, and output called Z. So this is X, this is the Z. All right, so once you see this, okay, usually, okay, we are supposed to convert this part here into a state table, then design accordingly. But this question here also asked me to determine the input sequence where which is going to give Z a 1. Okay, and the first state is A, and they tell you that overlapping sequence is to generate a 1 at the output. Because if you were to trace, they are going to sort of, okay, generate a 1 again at the output. So in this case here, we go through it as A, always, okay, move on, okay? You saw a 1. So you have a 1 comes in, a 1 comes in will cause you go to B. So always move forward, okay? They are going to give me a C. Then later on, move forward, they are going to give me a D if 0 is the input. Then move forward again, they are going to give me a E, okay, which is the 1, 0 again. So after E, they are going to go back to E, okay, go back to 0. With a 0, go back to A. Oh, okay, sorry. This part here, no, because you see output is a 0, and question tells you that, okay, overlapping going to generate a 1. So if last one is a 1, okay, if last one again is a 1, okay, they are going to continue from C, and they output you a 1. So this is a part. You see in the whole sequence here, only this one here give you a 1 for the Z. And question say that, okay, overlapping sequence is going to generate a 1 here. So that is to say that, okay, if it's 1, 1, 0, 1, 1, okay, and you have 0, 1, 1 again. Now, these are parts here, my output, okay, will give me a 1 here. Overlap from here to here, I get another 1 for my Z. So Z0, 0, 0, 0, 4, 0, and here you get only, this is under this 0, this is the 1. Okay, so you find that you get Z, okay, more faster because, okay, you continue, go back to C. Okay, so okay, input sequence is this one. All right, so with this, okay, now I'm going to design using JK. All right, so fill in the time, careful, careful, don't make mistake. All right, so this is X when 0, X when 1. So 0, 1, 2, 3, 4, 1, 2, 0, 1, 1, 1. Okay, correct. This one 0, 1, 0, 0, 1, 0, 100, 0, 1, 0, correct. Also, okay, every 2 or 3 draw a line, easy to see. Otherwise, it's full of 0 and 1 and plus some, don't care. Okay, so then this one 1, 2, 3, 4, all 0. Okay, correct. And actually, I didn't do this part. I straight away, okay, fill in into the Kano map. So I'm not going to check for these parts here. Okay. Question only asked me to go for state transition table showing the excitation required by flip-flop P, Q, and R. Oh, yeah, require, okay. But because my one is a marking script, so not necessarily. Okay, so require, must do it. Okay, must do it. And then fill in into the Kano map. So I double confirm with the Kano map. Okay, if it's correct, then that part will be correct. So this is 1x kp. 1, 2, 3, yeah. R. 1, 2, 3, 0, yes. X 0. So correct. This one here 0, 1, XO, 1, O, X 0, X, 1, 2, 3, 4. Yes, 1, 2, 3, 4. Okay, the output, okay, that one never prepare the Kanu map, so a little bit high risk, okay, because we have don't care. Okay, never mind. Later on, okay, we check the output parts, okay. Okay, Q R Z KP 1 R X P X R X Q. Okay, so this is correct. So what is missing? Only maybe the Z. Z, I don't think, okay, it is so complex. Okay, my Z only, my Z actually same as the PX only. Okay, now this is because, okay, I prepare Kanu map for my Z. So maybe put it at the side here. I find OneNote getting very slow already. Maybe the user getting more and more. So my Z here. So PQ. So I have is a 1, 2, 3, 4. 1, 2, 3, 4. But don't forget, okay, I have a few don't cares over here. Okay, because of this don't care, okay, I do this looping that make my P here become PX, okay, same as the Z, okay. All right, so this is the part, all right, that we need to do. So, okay, so okay, confirm that this is correct. So your clock. Okay, here this label is here PQ bar. Yes, good. This is my X. So I don't check all this first. All right. So in the exam, of course, I will check. All right. Now I take it as correct. Okay. This is R. KQ. KQ is R. KQ is R. Okay. So any questions for this part? So done, right? So it's not difficult at all. So just cover all the basic things. Okay, third question done. So we now look at question number 4. I think if I'm not mistaken, okay, we already discussed this question. Am I right to say that? Am I right to say that this question I already discussed? Because for this part here, I put in a lot of this past year paper. So if I already done, so I am going to skip. Nobody answer me. Are you still there? Okay, we look at this one only. Done why? That question I already done, right? In the tutorial? Done already. Okay, so check tutorial. So I skip that question. And now we look at question number 4B. 4B, based on the ASM chart, okay, I am going to build this table here. So I have a present state, S bar, a bit small, so okay, confirm one by one. Okay, so this one here, XOR, X no, XOR, XY bar. Okay, 010, X 100, 101, 10X, 10Y, 100, 101. X00. This one, no conditions. I need to go back. Yeah, this table here is correct. Then supposed to sort of, okay, build up this circuit based on this table. Okay. Let's see what is the requirement of these questions. In these questions here, control unit using this one. The next page. No more. Oh, okay. With a suitable table, design the circuit of a control unit using multiplexer, D flip-flop, and a decoder. I only need this one here. All right. Multiplexer, D flip-flop, and a decoder. So therefore, this part here, no need. Okay, no need. Or not required. I should put it as not required. Okay, not required for all these. Okay, all not required. So what I need is only this parts here. Now, a bit small. So I have this one. This 1, 2, 3, 4, 5, 6, all shorted to ground. Yes. All right. Then this is a Y bar, X plus Y, all 0. You can all, okay, join them together. Okay. You can just draw it as, okay, all join together. Ground. Also can. X. All join together. All right. All join together. Forms your ground. Then this is the part that makes sure, okay, connection is correct, which is the most significant here. Okay, this one here is going to generate my A. A is the one that go to S2. This is the one that generate the B. B go to S1 center. All right, and C this. Okay, one thing is missing here. This circuit tak boleh jalan because the clock hilang. Okay, no clock here. So center, yep. Okay. Then lastly, T0, A is the most significant. Yep, correct, except the clock here. Okay, this paper done. Jangan forget about clock. So finish design, circuit tak boleh jalan. Always check your clock, okay, whether connected properly or not. Okay, anyone with any questions? For those who haven't do revision? The tutorial one is SR and JK. That is to say that I haven't discussed the part A. All right, no problems. We look at it. Part A, part A. Where's the part A? Okay, part A. double confirm that this is correct. My answer A 11 1100 011 Let me check one by one first. Okay, maybe I should start off with expressions. Okay, my JAKA is given as x bar plus B. Yes, x bar plus B. Okay, JB is easy, KB also easy. What about my Z? Z is given by this one. Yeah. So with that, okay, we fill in those expressions into the table. I go for this one first. 0, 0. This is all 1, 1, 1. 0, 1, 0, 1, 1, 0, 1, 0 for my B. Okay. My Z. Okay. This is my next state. Next state 1, 0, 1, 0, 0, 1, 0, 1, 0, 0, 1, 0, 1, 1, 0, 1. Yes, correct. Okay, then based on this table here, I think question never asked for this one, but I say, okay, no harm doing. All right, no harm doing. But of course, in the exam, read the question unless you've got a lot of times. If not, okay, do whatever you are supposed to do. Enough already. Okay, first one here, you start from 0, 0. It is going to go to 1, 0. If x is a 0, output is, where is my output? Which column already? Okay, output is a 0. Okay, if it's 1, they tell you that, okay, never move. Okay, so now I managed to get the first one. Then 0, 1, if I start from 0, 1, you also go to 1, 0. Both also go to 1, 0. Both also output you this one. I'm at 1, 0, okay? If 0 comes in, I go to 0, 1. Hey, 0, 1 is here, ma. All right, so you take either one of, okay, either one. So this one, 0, they go to 0. 0 output you is 0. Then this one here, so this part here, the one, this one, 1 go to 1, 1, correct? Next, I'm at 1, 1. I'm going to go to this. I also go to this, okay? Yeah. So this part here, remove this part. Or Tangma, you actually want to remove this one, is it? Because you have this one also. All right, so this one you have. This one you have. Okay, so remove the this one. So this is correct. You have it over here. So this is no need already. Take away, take away. Okay, so what we need to do now is actually remove this whole thing here. Easier. Okay, so this whole thing here don't need because already cover here. Okay, done already. So with this, then it is correct. Okay, remove this one, then it is correct. That is to say that, okay, my 0, 0 here actually is an unused state, not used. Okay, it's something like you don't care. So if you start from here, okay, you must make sure, okay, you put an input to it so that it joins back the main loop. Okay, if it's 1, you input a 1 here, they always, okay, stay in these loops here. And with this output 1 here, they can set it to an alarm. Say, for example, it's an alarm or so. Okay, hey, how come my output always 1? Because, okay, it is in this state here, which is not moving on. Okay. Okay, so class completed this paper here. So another one to go. So we take a short break. Is that all right? State transition table is not include this. What are you talking about? Not very sure. Tang Wai, cannot understand your question. The state diagram. The state diagrams here. Yeah, this is the state diagram that you are producing. Okay, you produce this state diagram, and you find that in these states here, okay, if it's 1, they always loop, 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 isn't it? If it's 0, then only they can circulate, okay, or go to their different groups or different states lah. Now I'm trying to explain to you here is this one here. If this you see, okay, diagram like this, okay, usually this is something like a certain unused state. You are not using this state. State transition table. This is the state table. So this question never asked for this one. Not required. Okay, maybe I should put here is not required. Not required by question. Like I say, okay, tutorial we do all because tutorial okay. But this one here, this exam here not required by questions. So in the exam that time, okay, read the questions. Okay, unless you have more time, you want to do extra, never mind. If not, okay, so answer according to the question. Okay to all? Then we'll look at the next paper afterwards. So this is now 17. So take a slightly longer break, a few minutes more. So we start continue at 7:30. So 1.5 hours to be able to finish. Okay, we continue. And I was just marking just now 2 questions.